We'll be using Arrow Studio, which is this. So you can see this is Arrow Studio. So before we do anything, let me just go through the data, the interface. Arrow is quite different from Jupyter Notebook, which we know already. And this is the way Arrow works. This window is where you do all your typing. So this is where all the typing happens. You can type anything you want to type. That's where all the typing happens. When you create a variable, it pops up in the global environment, this window. This is where your variable names and the values appear. You will see them here as you create them. In your plot, this is where any plot you create, it shows up here. This is where it shows up. And with this window called the packages, this is where all the libraries you have to install, all the dependencies are found. So in the future, we will be installing our own packages that we will use. All of them would come here and live here. Then this is the console. The console is what shows the result of all your operations. Unlike Jupyter Notebook, where anything you run in a cell shows under. This in Arrow, anything you type here, the output is displayed in the console. So if I do 2, let's say 3 multiply 6, see the output, it pops up in the console. All your operations, the output will be displayed in the console. So if you do too much operations and you want to clear the console, you can use this broomstick. Or once you click on it, it cleans everything in the console. So you also have the same broomstick here. So if you click a variable name and you see that name is equal to beauty, and you execute it. So you see the variable name called name, and you see the associated value, and it shows in the global environment. And if you're tired of seeing too much values here, you can always broomstick it and it goes away. Now that will be all we'll talk about. That's basically all the windows you need to know how to use. This is your IDLE, where you type your code. This is the console. Everything you do comes to the console. Yes. Any line I run, it appears in the console. So if I do second name is equal to bright, you see, it also appears in the console. Pretty much everything comes to the console. That you should just bear in mind, that everything comes to the console. And the global environment displays all your variable names and their associated value. While packages show you all the dependencies you have and all that you will install in the future. Plot is where all your visualizations come to. So anything you plot, it appears here. Anything you plot will appear here. We will get to that part soon enough. So that is the concept for plots, packages, and files. You wouldn't use this one too much, but this one just shows you, it's just like it's a browser where you can access your documents through it. All right. Does not have what? Where you can type. All right. So if you're opening Arrow for the first time, stop pressing. If you're opening Arrow for the first time, yours should be looking like this. Right? Is anybody's own that is looking different? Okay. So the reason why you're seeing that is because there is currently no active script. So To create a script, you click on this plus icon, this green cross, and you select arrow script, or you do Control Shift N. So if you do press Control Shift N, it should open a window like this. So two ways, do this and arrow script, or you go Control Shift N. This was it. Why are you shaking your head? You're supposed to be nodding the head, not shaking the head. When something works, is it not? Your excitement is like this. All right. Danny, how about your own? Is it up? Okay. You installed it on Friday, did you? From Anaconda. Okay. Our studio. Okay, that's all. All right. Now let's look at the core programming principles, and we'll be moving very fast because most of these things you already know. What is it? Yes, we're moving fast. So we'll talk about the core programming principles. No, you can only comment. No. Yes. The same pattern. Hashtag or pound sign. So first thing, now this when we say core programming principles, this is something that is applicable to all programming language. That's what they are called, programming principles. Then we'll look at the syntax and the principles that are unique to R, what makes R different from Python and the rest. So the first thing we'll talk about is variables. And data types. So it says you don't have pen and paper. Forgot it. Alright, data type number 1. I say you should stop. As if this one I should open. There's no pen. Somebody, who did I give my pen last time? That person has taken. Something is telling me to Joyce and borrow my pen. Yeah, I don't have pen. I don't know why. So characters are these. Anything inside a single or double quotes is a character. So if you have something like this, or you have something like this, 1, 2, 3, 4, these are equally characters. Characters are the data types you would call strings in Python. They are characters. Then the second data types are numeric. Under numeric, we have a couple of data types. We have the double, we have integers, and we have the complex. So one very important thing to know is that in arrow, a double is, if we say a value, if I just say 3, is this a string? Or now doubles are what you consider to be floats. Just take it that doubles are things you consider to be floats. So a number like this, just 3, Where do you classify that? String or float? Integer or float? Integer. BTU to integer. Okay. In arrow, this is a double. It's not an integer. It's a double. So this 3.5, 4, 4.0, they are all doubles. In arrow, everything is like a point zero. So 4.0 and 4, any operation, they will give you the same value, right? So arrow sees like everything is a point zero. So to define an integer in arrow, we need this L. So if I say 3L, now this is an integer. 100L, this is an integer. You have to specify the L. It's what defines the integer. It has no real world meaning. It's just an arrow. If you don't specify the L behind the number, it's a double. Because arrow does a point zero of everything. So if you're just saying 3, arrow is doing 3.0, which makes it a double. But until you say 3L, then that makes it an integer. Then a complex looks like this. 3I, 4 plus 5I. Any value you put this I with is a complex. Any value you put this I, lowercase I, is a complex. That means it's a complex number. So complex numbers are mathematically, complex numbers are the result of a real and an imaginary number. So that's a complex number. But in arrow, complex you won't use very much. What you use most of the time are doubles because your data set, if you import a data set from anywhere, nobody is typing L in the real world when they are collecting data. So most of the time, when you get a data set, it's going to come as a double because people just put numbers. So if you have a column that collects somebody's age, right? Nobody is collecting people's age and is putting 30L, 12L. You get. So you're only going to be getting like 30, 12, 14, just the normal age. So once that data comes into arrow, it becomes a double. That's why for the most of the operations, arrow we are going to be using doubles the most. You only get integers when you personally specify it to be an integer. So that's it for the numeric. 3 numeric types: doubles, integers, and complex. But you use the double more than the others. Then you have the data type number 3, the logical, which are Boolean values. So logicals are Boolean values, which are true, uppercase all, or uppercase T, and false, uppercase everything, or you just do uppercase F. That's the logical. They are Boolean values. These are logical, true or false. What else again do we have? Punctuation. No, no. We don't have dictionaries. We have lists, but you'll be shocked to see that the lists are data frames. If you check the type of, when we get there, you'll see how it works. All right, let's get down to arrow. Okay. So, in Python, we have type. That's method called type. Arrow, we have something similar, but it's called the type of. So if I check type of 3, to run a line, you run arrow line by line, it's control and enter. So control enter, and it shows me this is a double. And if I do type of 3.0, it also shows me this is a double. Now if I also check the type of 3L, uppercase L. Now this is an integer. So what happens when I do, yeah, Mrs. Beauty? Yes. Repeat. No, 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 no. We'll use this control. This one is not. Zero's coming up. Make sure your cursor is inside here. Then do it again. Use this control. Don't do that one. Use this control. This control.
Yeah, they don't give space. Everything is together.
Press enter. What's this? How is the collab? Why is it giving me that? Skip this.
Yes,
Type again. Yes. How about yours? You didn't create a script. So you are typing inside the console. Wow. Okay, so what if we do something like this? Let's see, what if we do type of? If we do type of 3.5 L, now see what the message is. Warning message: integer literal 3.5 contains decimal using numeric value. So you can't pass simply because a regular 3 returns a double doesn't mean you can do a point anything and throw in an L to say you've converted to integer. It doesn't work. As long as you have this point, it's going to tell you it's not going to work. But 35L, definitely an integer, no problem at all. So that's it for the numbers. Then if we do the type, let's look at a complex. Type of 3i. This is a complex number. Like I said, complex and integers, you will not find yourself using very often. You will find yourself using doubles more often than you would imagine. Then, characters, anything inside the single or double quotation is a character. There's no point stressing it. So let's move on to variables. Okay, it's not on logical. So type of, if I do just uppercase T, it tells me it's a logical data type. And uppercase F, so you can type true and false, or you can just do uppercase T, uppercase F, and that's all you need to see. Are you done? No. Yes, Bob is right. Don't save it, it's gone. You don't save it, it's gone. But it usually prompts you to save before it goes. Like if you're trying to log off, that one is on you. Don't have light when your system goes off. That's on you. It's all gone. So I would advise you to save with every step. All right, let's talk about variables. And this is something you're already used to. You have the variable name on one side, and you have the variables value. And I like the way arrow illustrates this logic, because in the global environment, you see right here that you have the name and the value. You have the name and the value. So if I say that value, that's too cliche for a variable name. Length, right? Length is equal to 7.5. Take 7.5. Instantly, you see length, the name, and the value appearing side by side. Very, very nice. I really like the way they do it. They do this in Arrow. Very nice. The name and the value side by side. You cannot space. You cannot. You want to do this. You cannot do that. Spacing in between. So instead you underscore. There is no way in programming where that thing happens. I've not really seen, not in Python, not in Java, not anywhere. Everybody is good. So one other cool feature that Arrow has is that you can remove a variable name from your environment. So this is, I'll call this test name. That test name is equal to some random value. Doesn't matter. So test name is equal to random value. If for some reason in my environment, I don't need this value again, I can delete it. So I'll say rm and I'll put in test name. And when I execute it, notice that in my global environment is gone. So the RM just simply stands for removing. So you're removing the values you don't need anymore. So another thing we should know is that in a previous versions of Arrow, assigning variable names used to be like this: a less than minus 10. This was how you assigned variable names in the past, like this, using less than minus. But now we are using this. So just know that less than minus is or was how values are assigned. So I can do A. If I do less than minus 10, you can see it here. It appears there, less than minus. So this is old actually. It's very old, but still works. So either ways, still works. Now you can do what's the you can do operations. So if I have A to be 10 and B is equal to 20, we can do operations, basic operations by saying C is equal to A plus B. And C is 30 here. And if you want to see that in your console, all you do is say do print C. Normal print you know from Python. Print C. And is that a case problem? Alright, so that's lowercase c. So now it shows up in the console that C is 30. Any operation you can think about, plus, minus, divide, subtract, all of them can go through. There is absolutely no problem. Alright, let's look at logical operators now. Fortune, are you with us? Alright, logical operators. So we know that logical operators are, let me just give you a note for those people that don't know. Logical operations are basically comparisons between two or more values which always, it's not sometimes, always result in a logical. Now, when I mean logical, I mean truth or false value. That's what they are called logical. And I believe for the first time in Arrow, it makes more sense than any other place. Because Arrow considers the Booleans to be logical. So if we say an example of logical operation would be 4 less than 5. And the result would be false because 4 is not less than 5. Another operation could be 10 greater than 100, which will also be false because this is not true. And we can also do 100 greater than 50, and this will be true. So we are interested in the output of the comparison. That's the logic behind it. And we know that the logical operators we have are less than, greater than, not operator, less than or equal to, greater than or equal to, the and operator, the or operator, and we have this very special one in arrow, the is true. And we're passing an integer x here. Joyce, this not operator, what does it do? This guy. You're not sure. Say the one that you're not sure of. Say it now.
Should I do that?
Mm, yes. Uh-uh. It flips the result. Whatever the result is, it flips to the opposite. Now, if I say, if I do something like this, if I do not 4 greater than 5, this is true, right? This is false. This will result to false, naturally. But because of the not, it will flip it to true. So whatever the output is, the not operator flips it. 4 greater than 5 is false. True or false? But the not operator is going to flip it. So whatever that operation results to, the not operator flips it. And then of course, you know that the AND operator will only return true when all comparisons return true. And the OR operator will return true as long as at least one comparison is true. So the only new thing here is the NOT operator. The NOT operator flips whatever you get. I also have the double equal sign, which checks if two things are equal. Or. Or. Yes, that's how you like to point in arrow. We are good. All right, so let's look at a little bit of practice, even though we check your casing. Check your casing. Are you doing uppercase or lowercase C? Upper. When you created your C, was your C upper or lowercase? It's upper. Then your casing is not correct. Change the casing and run it again. It's working now. Now we'll say thank you. You're welcome. So let's create two variables we'll work with. Okay, we already have A and B, right? We already have A and B. So if we do A, why am I using uppercase? It to stress me. A less than B, that's true. The logic is the same thing. Nothing has changed. It's the same thing. So A less than B is true because A is 10 and B is 20. So if we check, if I do not A less than B, this will turn false. Because the not operator flips whatever the output is to the opposite. It just flips it. So A less than B, which was true, now becomes false. Then we use the is true, which I like so much. Is true just makes everything simple. Is true will return true if it's true. To return false if it's false. So it's true that 10 is greater than 100. It just says false. That is the is true. That's all it is used for. Any questions so far, please? Any questions? No questions. Daniel, have you gotten any topic? No. You don't find anything interesting yet. You're saying mark down. Mark it down. I don't hear from me. You're saying mark down, mark down. Okay, let's go. Now let's look at functions. Class is going fast. I like it. Has anybody heard anything from Victor? Nobody. Oh, we get the functions. Let's do loops. And of course, there are always two types of loops. Number one is what? While loops. Number two is what? For loop. And we know that the while loop will continue to run as long as the initial condition is true. And for loop is used when you want to iterate through a range. So before we look at for loop, we need to look at how we create a range, like a list or an array in R. Because if there's no range, there's nothing to loop through. We cannot iterate. So we have to create the loop first of all. But since while loop doesn't require a range, we'll touch the while loop first. So the principle remains the same, just a change in syntax. In our syntax, the while loop looks like this. We'll say while, then you take a bracket. This bracket is going to hold your comparison or your control value. This thing remains true. Look at the screen. So far as whatever is here remains true, this loop will continue to run. So while true, print hello. And this is the arrow syntax for a loop. Very simple in it. Very, very simple. Where is all these trust issues coming from? Yeah, she's complaining. Like, you not tell people that they are inviting her for competitions worldwide. You not tell people they are inviting for competition worldwide. Like, no nothing. This person doesn't do anything. You can put it anywhere. Okay. Brackets, no. No. This is print hello, the normal print statement, Print hello. Normal print statement. This is not a list. Okay. This is a loop. So you do while, then you put your condition here. You open this, very compulsory. You type whatever command you want to continue to do, and you close it. Now, don't run this, please. yet. Don't run it. You've not even typed it. So let me be the first. So I'll say Y. And R is very nice because once you hit enter on the Y on this, it will just drop the syntax for you. So watch Y. And you can see it did everything. While you put a condition here and it closes it. So if I say Y true, now this condition must be, remember you can use uppercase T for true. Then here I will say print and print hello. So to execute this, you highlight the loop and you execute. So it's going to continue printing hello until I stop it. So to stop the loop, you always use that. See there, let me run it again. You need this. This is what stops the loop. I will sweep it out. So why through print that? So note that whatever condition you put here has to be true for the loop to start. If you do this, if you say while false, this loop will never run. Print hello. This will never run. This would work. This would never work. Why? Because the condition here is false and the condition here is true. So this loop would run. This loop would not run. It has to be true for it to work. All right, now let's do something. What we want to do now. So let's say number is equal to 1. We will now say that while, so the condition now is while number is less than 10, print number, then number plus 1. All right. So this should print this should print 1 to 10 and stop. Oops. Not giving what am I missing? I'm missing something. Missing something. Okay, counter is the number should be equal to, yes, number plus 1. Exactly what I was missing. So this should print 9. All right, because I say less than. Basic while loop. Again, you won't be using much of this. It's just we are learning how for data visualization and machine learning. So we'll be cutting straight to the point. But there's no light now. Yes, so customer satisfaction is our priority. What can we do to improve your experience? You're not considering your fellow students. No fortune to turn into light. Are you saying customer satisfaction is our ultimate priority? Stop drinking Gabby, no, yeah.
This one,
Yes, it's because of the conditions we set. We say that number should have this value, and as long as its value is less than 10, you will print the value, then we reassign it to add the value of 1. So every time it prints, we add +1 to it. So anytime it tries to be greater than 10, the loop stops. That's why it's like that. No, R doesn't save automatically. Okay, so simple while loop, that's done. We're not building software with R, it doesn't do much. Let's look at a for loop. And for loop, like I said, for a for loop to work, there has to be a range of values because for loops are used to iterate through the range of values. Now, to create a range in R, all you have to do is define your start, take a colon, define your stop. And sometimes you define your step, optional. So if I say 1 colon 10, this will print all the values from 1 to 10. And arrow doesn't start counting from 0. It starts counting from 1. So if I do this, if I say 1 colon 10, so you can see in my console, I have all the values from 1 to 10. That's fine. So let's look at how that will work in R. So we'll say that x is equal to a random number. So we're taking one random number. Now we'll see that if it is true that x is greater than 1, oops, if it's that x is greater than 1, then it should print x is greater than 1. Then